Hi, I'm Chris Hoskins, and this is my heat transfer project. So what I decided to do for my project is to study the behaviors of heat transfer while baking a cake. Now originally I was just gonna put different types of material and water, come up with a heat or with the like transient equation, with known thermal conductivity and measurable temperature, but that seemed pretty boring. And this project not only is a lot funner, but it includes all three types of heat transfer: conduction, convection, and radiation. Okay, so what I'm going to do is I'm going to go through my MATLAB code just to explain how it works, and then I will show you what I'm doing. Okay, so we start at the top here. So the first thing we do is, and just so you know, so you're aware, a lot of these numbers had to be looked up because it gets really disgusting. Like when trying to, the math can be really disgusting. If you actually tried to go in and do all that. But the point of this is to demonstrate my understanding for heat transfer and what I've learned in the class. Okay, so we start here. We have based on research, this is the surface temperature of the pan/batter and the temperature of the air, or T infinity, and then we get the mean temperature. That's where we're gonna evaluate our properties at, or the mean temperature between the surface temperature and T infinity. And of course we have our acceleration due to gravity, Stefan Boltzmann constant, which will be used for radiation. And then we move on to air properties. We get the volumetric expansion coefficient by simply taking 1 over the mean temperature, or 1 over TF. We have the kinematic viscosity alpha, which is the thermal conductivity over density times specific heat capacity. They're all properties, so this is all just one. I don't know. There's no point in getting all three of these and then calculating when you could just look up when this is a property itself. But we do need the the thermal conductivity, which we have here of the air, and then the Prandtl number. Okay, so that's the properties of the air. Now, properties of the cake. Now, based on research, these are the numbers that I came up with. We have the thermal conductivity of the batter before it's cooked, and the thermal conductivity after it's cooked. And to simplify things, I simply just took the mean of those. Okay, and then this would be, according to my research, the emissivity, which will be useful for radiation. Okay, now on to the pan. This is the thickness of the pan. Oh, and by the way, all the measurements are in meters, or all the lengths are in meters, and all the temperatures are in Kelvin. And then this is the thermal conductivity of the pan. Geometry of the pan, this is the pan size, and we use that to get area and perimeter. And then with that, we can get the characteristic length by simply taking the area over the perimeter. Okay, so with those calculated, now we go into our system of equations. I'll go through each equation. So I was able to come up with 11 equations with 11 unknowns. And this is a function in MATLAB that you can use to solve a system of equations. Okay, so first equation is simply the overall heat transfer coefficient. We have there's radiation, there's heat transfer due to radiation, there's going to be heat transfer at the top, and there's going to be heat transfer at the bottom. Okay, all those when combined will equal our overall heat transfer rate. And I guess I should mention, we're going to assume natural convection. So, because, I don't know, there's, from my experience, I think ovens behave more like natural convection. So, with that being said, we have our Rayleigh number. This is simply the Rayleigh number equation. And this is our QRAD, or heat transfer due to radiation. So now we move on to evaluating the heat transfer at the top, which is what equation 4 is, but we also need the resistance, the thermal resistance at the top, and the the convection coefficient at the top. But to calculate that, we need the Nusselt number, and this is the based on the material. This is the Nusselt number correlation based on the facts. Okay, so now bottom pretty much the same thing. Got our heat transfer, thermal resistance, heat convection coefficient, and the Nusselt number. Okay, and so with that we have, again, 11 equations and 11 unknowns. So from these equations, we'll be able to get our overall heat transfer, heat transfer due to radiation, heat transfer at the top, heat transfer at the bottom, our Rayleigh number, thermal resistance at the top, the convection coefficient at the top, the Nusselt number at the top, the thermal resistance at the bottom, the convection coefficient at the bottom, and the Nusselt number at the bottom. And we set those into these variables, S1 to S1, S2, S3, all the way to 11. Okay. So after all these are solved for, these are all of our solved variables, all 11 unknowns from the 11 equations, and then the user can decide which one of these 11 variables they want to display here. So for example, let's say I wanted to know what the Rayleigh number was. Yeah. Okay. So then we run it. As you can see, it displays it right here. So that pretty much concludes my MATLAB code. I guess I'll show you what I'm doing. This is my cake, or my batter before I bake it. I'm about to put it in the oven. It's already preheated, so yep, I'm excited. Thank you.